inequality is like things that overlap. So it says a compound inequality containing the word and.
This is the last call for pictures. Any junior who has not got their picture taken, please report to the comments. This is any 11th grader who has not got their picture taken, please report to the comments. Also, if you are any other grade and you did not get your picture taken, please report to the comments. This is the last call.
It's true if and only if both inequalities are true. And so that's why I always think that and meets in the middle, because they overlap. So it says like x is greater than or equal to -4, and x is less than 3. It's where both of those are true. So to kind of show you what that looks like if you were going to graph it, I'm going to use different colors. But if I was going to do everything greater than or equal to -4, that would be a closed circle, and everything greater than or equal to -4 would be like that. And then everything less than 3 would be an open circle and shaded in this direction. The and inequality is where both of those are true. So for the most part, people remember you just shade in the middle. So they mark like -4 to 3, and they shade in the middle. So like your solution is really just that part in the middle. Like they both have to be true, happen at the same time. Another thing about and inequalities is you can write them all as one thing. If that confuses you, you can always separate it. But as you can see right here in example 1, you can always write them as one thing because it's at the same time. So another thing that you could do is to write this. I could say x is less than 3 and it's greater than or equal to -4. But notice if the x is in the middle and I want to put the -4 on this side, I have to keep it where the pointy side is towards -4, which means I'm actually going to flip this around. And I can say -4 is less than or equal to x, which is less than 3. And we can only do that with and inequalities. And I was reading about this because someone asked me in my pre-calculus class why with and inequalities is all together and why is or inequalities separate. And it's because in an and inequality, if we took this x out, that's still a true statement. -4 is less than or equal to 3, so if you just forgot about the x. So that's why you can just squish it all together to do that. So this is how your book's going to give you these. So when you see it all together, that's an and inequality. And you can solve this. So let me see if I can do this. 10 is less than or equal to 3y minus 2, which is less than x. Remember doing these kind of problems before? So we've basically taken two inequalities and we've squished them all in one because it's both true at the same time. So you can solve this inequality all at once. So just like if this 10 wasn't here, to solve for y, I need to get rid of -2. So I'm going to add 2. But the difference is now I'm adding 2 on both sides. So that means I have to add 2 to 19. And I also have to add 2 to the 10. I'm not adding 2 to the 3y because that's like the part that's all together already. Follow me on that? So then I get 12 is less than or equal to 3y, which is less than 21. And then what would I do? Divide both sides by 3. And I would get 4 is less than or equal to y, which is less than 7. Because we know the proper way to write inequalities now, you have two options. Your solutions need to be in either set notation or interval notation. So set notation is what your Algebra 1 book does. And set notation is really not that bad. You just do a little squiggle, draw a line, and then whatever letter's here, you just say y, and then you do a little squiggle. And it might seem silly, well, why can't I just leave it like that? This is the notation saying that the solution is all y's such that y is between 4 and 7. So if you're okay, if you want to just make the squiggles, draw the line, that's an appropriate answer. Or you can do what we did yesterday, and you can say, okay, here's my inequality. Since 4 is included, I'm going to say bracket 4, 2, 7, 7's not included, that would be a parentheses. You have to do one or the other. You don't have to do both. Addie. It's just one or the other. Okay, I will tell you on this first test, I'm going to have a couple questions over interval notation, just because I want you to be aware of it. But when you solve an inequality, so the questions on the test will be over interval notation. If I say, write this interval notation, here's the interval graph thing. But the actual solving, my directions will say you must write your answer in one or the other. Okay? Other questions about this? I think this says to put them on an underline. That was free to do that. But if you know how to write it like this, I feel like you know how to graph it. And some people on their homework quizzes yesterday, I was so impressed with how many numbers they put on their number lines, and I must do a really good job of making you make number lines, because I'm really lazy when it comes to number lines, and I always just put the numbers that are required. 4, 4, and 7. And because it is included, that's a filled-in circle. 7 is not included, it's an open circle. And it kind of just verifies that that's true. Everything less than 7, that's bigger than 4. And again, if you read it like this, it does say y is greater than or equal to 4. But we just have it switched around to type. So questions about that? Or yes, because and is just where it has to happen at the same time. Yes. So you're only shading what's in the middle. At the top, I was trying to show you where it overlapped. Okay? So you try this one if you haven't already. See if you can solve right. Put it in set notation or interval notation. Okay, no, I had never looked at before either. Okay, so I'm going to subtract 5 from each side. Think about these as equal signs. So I get 6 is less than or equal to 2x, which is less than 12. Oh, look how perfect these all work out. Life doesn't always work out so perfectly, so it's okay if you ended up with something here that wouldn't divide evenly and you could get a fraction or a decimal. So don't freak out if that happens. Something else to remember, if this was a -2 here, we would have to flip these signs, and that happens as well, because if you multiply or divide by negative, you have to flip your sign. But this is 3 is less than or equal to x, which is less than 6. So I like interval notation. So if this was me, I would say bracket 3 to 6, parentheses. Some people say, well, that's just silly. I would much rather do set notation because I can just do squiggle, line, x, squiggle, and that's way easier for them. I don't care which way you do it, okay? Questions on where I got those numbers? I'm a slacker and it doesn't say graph, so I'm not going to graph it. But it would be everything between 3 and 6. The only other thing we're doing today is an or inequality. And an or inequality is this or that. Sometimes you get an invitation to a wedding and you get to choose your meal options. You choose chicken or fish or beef. You can't mark all 3. It's this or that. So and happens at the same time, where it's included, or 2 separate things. Normally, ors are shaded in the opposite direction and shaded in the middle. And so it says, Or is true if one or more of the inequalities is true. So either this could be true or this could be true. Doesn't have to happen at the same time. It's really easy to recognize an or inequality because it always has the word or in it. Alright? And all you do is it's like a 2-for-1 problem here. You just have to solve both inequalities and graph both on the same number line if you were going to graph it. Alright? And that's where we did one of those yesterday on the integral stuff. So, hopefully these don't feel so bad for you to solve. You're just like, oh, I'm going to subtract 3, and then I'm going to get x is less than -1, or I'm going to divide by -1, and what happens on this one? Dividing by negative, I have to flip this around and get x is greater than or equal to 4. So this is where interval notation, you have to set up 2 intervals. This is where some people are going to be like, I'm totally choosing set notation. Because set notation, you can just say squiggle, line, x, squiggle. Squiggle's not the official math word for that, but I think you can call it a bracket, just like you can call the other thing a bracket, but I think that's confusing. I think you can call it a brace, but I think it's I just say squiggle. I didn't know how to make those, so I was at college, just so you're aware. So if you struggle with the squiggle, then yours kind of looks like this. Just know I used to be there as well. So, I know what you mean if you make a squiggle. Interval notation. Remember, you just have 2 separate intervals. So everything less than -1, less than means I'm going to start with -infinity up to -1. Or, and remember you can write the word or, you can be fancy and make that u. Everything greater than or equal to 4 would be starting at 4 and going to infinity. Almost always, 4 inequalities go from -infinity to infinity with those spaces in the middle. So if you have a -infinity on this side and an infinity on this side, you probably have done that. So or looks like this. Not included, shaded to the left, or everything starting at 4 and shaded to the right. So or go like this and meet in the middle, except for rare cases. Like the rare Pokemon of our life. I don't even know what a rare Pokemon, but my son we play Pokemon every morning on our drive, and he holds the phone, and he's like, Mom, we need to go to this gym. I'm like, no, Parker, we're running late. We can't go to the gym. And then he always is like looking at what's at the gym. Oh my gosh, look at this Pokemon at the gym. I'm driving, Parker. I can't look at a Pokemon. Parker is my oldest. Nolan is my 3-year-old. And so they fight over who gets to hold the phone. So like we have like on the way to school you can hold the phone, and on the way home you can hold the phone. But Nolan can't catch Pokemon, so if a Pokemon pops up, he has to give the phone to Parker, because otherwise he just throws all the balls at it. But Nolan just says all the time, oh my gosh, there's this Pokemon! And then Parker thinks the Pokemon's there, but it's not. Like, it's just like in the sightings, or it's at a gym, or he's like, there's a new Pokemon! But it's really not. It's just like a Weedle, and so it causes fights in my car every day of my life. And I'm like, we're not gonna play Pokemon ever again! Okay, I was gonna have you go formative, but that's because before we waste a lot of time, so I'm just not gonna have you do that today. We'll just talk about Pokemon. Instead, I'm just gonna give you some problems, and then you can ask stuff. you have to try this. I was trying to see if you can maybe find an example of an inequality that doesn't meet the middle, or an equality that doesn't go like this. So just kind of, whatever you choose to put it later. Maybe next one. It's probably lost a couple feet. And then on the back, I just have a lovely little story problem. It's not even an integral or inequality, it's just a physical inequality. Okay? So we'll talk about that tomorrow. We'll talk about it. We'll take on what's it. No? Don't worry. Please ask me if you have a question, or if you want to do the first one and have me check it. It's a great thing to do while we have time left over before you do them wrong.